Alright guys, so let's start this. So looking at this question here, you'll need to know how to express this in a simpler form because in this course you'll have a lot of these questions to do in terms of splitting it into, I would say, smaller pieces to use it separately. Alright, you call this expression it in partial fractions form, right? It's fairly simple once you remember the steps as to how to do it, right? So looking at this here, this is a typical partial fractions question, right? So let's go to the steps. So these are the steps. So I'll be going through the steps with you all. I'm going to go through the steps and some things to keep in mind, and then we'll go back and to the question. So let's see how quickly we can do this. So the steps when you're trying to do a partial fractions question, the first thing you need to pay attention to, and this should be for all questions when you do partial fractions, is the denominator. If you forget the denominators, whatever is at the bottom of the fraction, and the numerators, whatever on top. The denominators where the action that's happened for partial fractions, right? So the denominator must be fully factorized. If you forget how to factorize stuff, make sure you go back and learn how to factorize, right? But always keep that in mind. Step one, you look at the denominator and figure out to ask yourself, is this fully factorized? Can this be factorized any further? If it cannot be factorized any further, leave it. All right, but that's the first thing you need to pay attention to, okay? The second thing, you need to, by analyzing the types of roots. So any denominator in its simplest form is going to be one of four types, which we'll go through shortly, right? Once you know the type, you just express it in its partial fractions form individually. Okay, let's keep that in mind. There are different types of roots. So you factorize the denominator, look at the types of root in the denominator. That's the second step. The third step is you solve for the unknowns, which we'll see shortly. And when you solve for the unknowns, you have two types or two ways in which you could do it. You could use the elimination method, or you could expand and equate the coefficients on both sides. This step a little longer, but it comes in handy for different types of questions. All right, so you should be able to do both at any given time. All right, then the last step, you just after you solve for the unknowns, in this case it will be known because you calculate it, you just substitute it back into the partial fraction equation, and that is it. All right, and you're done. All right, so that's the recap. You fully factorize, you look at the types of roots, you write each roots in its correct form, you solve for the unknown, which I'll show you all, and you substitute it back, and you're done. All right, so as I said, when you're looking in the denominator, after it's fully factorized, it will be in one of these four forms. It could be in more, but these are the main ones. All right, the first form is the linear form of ax plus b. All right, example, it might like have 2x plus 3, or it might like have 4x plus 5. Anything in that form, ax plus b, where a and b could be any number, linear. They call it a linear factor. All right, now when you're expressing a linear factor, it will look something like this. So let's say I had, we have one top, can't really care about the numerator for now. Let's say I had 2x plus 5. When expressing this in partial fraction form, it will be a that I already unknown came from over the same thing at the bottom. And obviously the step 3 will be solving for a, which I'll show you. Alright? So that's a linear. Linear repeated is basically a linear, but that's a star power. So let's say we had the linear repeated, we have a numerator 2x plus 5 to the power of, let's say, 2. Yeah? So you're noticing it's still a linear with star power. So it's a linear repeated. All right, and to do these, it's similar. So it'll be a by increasing in power. Say it's halfway lowest, which will be obviously 1. And then every time you go, you just add a letter on top, and you just increase the power. So it'll be 2x plus 5 squared, obviously. And this will stop at this. Yeah, so if it was 3, it would be 1, 2, up to 3. If it was 4, it would be 1, 2, 3, 4, and then you keep on going on the root like that. Yeah, so that's how you'll express linear repeatedly. Linear does always have one constant in the numerator, a, b, and so forth. Yeah, and the quadratic repeated, just for this video alone, I'll try that in our next video. But for now, we'll start with the easier one, which is the linear and the linear repeated. All right. So let's start with the first one, the linear. All right. So as I showed you before, this one, the linear. So it is of the form, you're looking in the denominator. Anything you see in its simplest form as ax plus b, it will be a linear root, right? So in this case, we have on top, denominator is 2x plus 4. This is a linear root, yeah, ax plus b. So as I just showed you, it will be a and 2x plus 4. Same pattern will continue. In this case, example 2, in its simplest form, you have 2x plus 5 and 3x plus 4. You'll normally get this when you factorize a quadratic, yeah? So you have two linear roots, and I repeat it, just linear. So that'll be a on the first one plus b on the second one. Yeah, very simple. Okay, and the last one, just bringing it home. You have y1 in the numerator, and in the denominator, in its fully factorized form, you have this, and this. So these are three separate linear roots. So that's be a on the first one plus b on the second one plus c on the third one. Yeah, and that is all. All right, so that's the linear. That's our linear roots. All right, and just to recap, remember the steps. So you need to know these steps, right? You fully factorize the denominator. After you do that, you write it in the normal partial fraction form based on the type of roots you have. In this case, we only know linear for now. And then you solve for the unknowns, which I'll show you all, and then you substitute back, and that is the same steps over and over. All right, so let's try this one. So same question, but let's go through the steps. So let's see. All right, first step, denominator. So we're looking at x squared plus 5x plus 4. Is it fully factorized? We try it in the calculator and see. So when you fully factorize that, it can be fully factorized, all right? So you'll end up with x plus 4 and x plus 1. Yeah, so now it's fully factorized, right? Second step, look at the denominator. What types? So I have a linear and a linear. So since they are both linear, so it'll equal to, it'll be a on the first one plus b on the second one. Yeah, step 2 complete. Step 3 now, so you have to pay attention to this. Step 3, all you're gonna do, you're trying to get rid of the denominator parts, which are these things at the bottom here. Right? So all you're gonna do to make it very simple for you, that's what I'll tell you. All you do is multiply on both sides by this. Literally, it does multiply on both sides by that. So watch what will happen when you do that. Wherever here is where you multiply on both sides by. Or else you don't look anywhere for it. Wherever here is where you multiply on both sides by. So we can multiply both sides by this. So watch what on this side, this will cancel with that, and this will cancel with that. So you just end up with 3x equal to, on this side now, when you multiply this piece by this piece, the x plus 4 will cancel, so you end up with a and x plus 1. And when you multiply the b and x plus 1 by this, the x plus 1 will cancel. So you end up with b and x plus 4. Yeah, real simple. All you gotta do, over here, you multiply both sides by it. And on the left hand side, this will always cancel. So you'll be left with whatever on top. On this side, one will cancel with the other one will be left, and you will end up with something looking like this. Yeah? And that is, you can call that like step 2.1 or something. Alright? So now we have up to step 3 now, where we have to solve for A and B. And as I told you, we have two methods to try, right? The elimination and the expanding and equating coefficients. So in this video, I'll just show you all the elimination method, right? So to use the elimination method, the idea is that these x's, so you're looking on the right hand side, you're looking at these two. So in simplest term, you're picking an x, in which one letter will disappear and the other one will stay. That's the idea. Alright? So let's look at A. If we're looking at A, if we want A to stay, we have to get rid of B. If we want B to stay, we have to get rid of A. And that is the idea. Even if you had like 5 letters, you want all the rest of the letters to go and one to stay. Yeah? So in this case here, since I only have 2 letters, and when you have like 2 letters or one, you could use elimination method. It's better when you have less constant. But when you have more constants, it's better to use the expansion and equating coefficients method. Yeah? So in this case now, if I want B to stay, A to go. Look at A. What X are the B? Remember 0 by anything is will disappear, right? So you're trying to get A to be 0. So what value of X will get A to be 0? Well, -1, right? Then -1 plus 1 is 0. So you just say let X equal to -1. So you plug it in. 3 by -1 is -3. Obviously we know this going to go to 0 because that was the idea. -1 plus 4 is 3, right? So it'd be 3B. So you solve for B, so B will be -1, right? Yeah, and then we go again, because obviously we want the other letter, which is A, right? So same idea. Now we want A, but we want B to go. Yeah, but if B go on A, we can be able to solve for A, right? So looking at B, what value of X I have to plug in here to get B to disappear? Well, -4, right? -4 plus 4 is 0. So you say let X equal to -4. So 3 by -4 is -12. Well, you know this going to disappear, obviously, right? But that was the idea. So -4 plus 1 is -3. So you get -3A, right? And you solve for A, so A will equal to 4. And we have solved for our constants using the elimination method. All right, so that's a recap. What the elimination method is. You're trying to eliminate one letter for all the rest of the letters and solve for one. Yeah, so to solve for one, all the rest of them have to go. Yeah, and you just look in the bracket and you pick out a number that will get it to go to 0. Yeah, and luckily for multiplication, anything by 0 is 0, right? And the last step, as I told you just plug it back into the partial fractions form that we had, right? So just writing it over. So you'll have 3x. I like to write it so like it will be x plus 4, x plus 1, and you fully factorize it. And that will equal to A, which is 4, on x plus 4. And then B will be -1 on x plus 1. And that is the step right. Alright, so that's a recap. Partial fractions, fully factorize the denominator. After you fully factorize the denominator, you look at the type of roots. Luckily, I have linear. And then you write it in the correct form for linear, right? After you do that, I showed you just multiply both sides by whatever on this denominator here on the left hand side. This will cancel, and this side, some stuff will happen. One will cancel, one will be left. And you'll end up with this line. At this line here, you have 2 options. You could use the elimination, which I use, or you could equate coefficients. Yeah, so I didn't do this as yet. I did this method in this video, right? So the idea for the elimination, you want one to go and one to stay. Yeah. So elimination is good when you have less or not much constants like A, B. If you have A and B, yeah. If you have A, B, C, D and stuff, it's better to equate the coefficients, right? But both methods will work. All right. Let's make sure you know how to use both. All right. And after you do that and you solve for your constants, you just plug it back into the form. Well, obviously, you wanted to find A and B. You plug back in A and B, and that is it. You're done. Yeah. And that was the partial fractions when you have linear roots. Alright, so next video will be going through the linear repeated. Alright, so be safe. All the best.